welcome to the session. In today's session, we'll be discussing about the software engineering process and some of the basic concept relating to software engineering process. Our main focus will be to cover some of the basic aspects relating to this particular process. As you know, there are multiple types of models, software models which are in existence, but our main focus will be on waterfall model only, and we would like to cover up the process accordingly. As you rightly know that waterfall model is one of the most used model in any industry, so I think that is going to be the right kind of approach. To begin with, what is the objective we have perceived for this particular session? Well, as I told you, the objective is to provide an introduction to software engineering and to highlight the process of software development. To begin with, or to start a software engineering project, or to start building up the software, what is the first thing which is to be performed in any software engineering domain, or for that matter any software development domain? Well, we must always start with something called strategic study, okay, that is, which is concerned with defining possible business problem systems, and the output which we get is candidate applications. Think of a banking environment. If I want to computerize the bank, I have to do a strategic study over there. The bank may be distributed. There are many branches, many places those branches are located, and person is allowed to withdraw money from any of those places. A strategic study is to be mooted. Probably the outcome which may come out of that particular strategic study may be that first, communication system is to be built. Number two, the intranet of information is to be built. Number three, the software for withdrawal may be built up. Number four, software for loan system may have to be built up, and so on and so forth. We don't know what kind of outcomes or candidate areas or application systems which may come out of that particular study. Our objective will be, so there are candidate applications. What will we do? We will do the strategic study to find out or to identify opportunities for software development. In fact, our main objective will be to prioritize opportunities. So there are multiple opportunities. As I was talking about the banking system, there are multiple opportunities existing, and what we can do with those opportunities. Probably the first opportunity which I would like to avail is, can I make a simple information system of each branch of the bank? Probably that priority is to be linked up with networking of all the branches of the bank, right? But to perform this kind of a thing, what I need to do? Probably I need to do something called a feasibility study, okay, whether the given application is actually feasible, given deployment is actually feasible, or is it not required at all, right? So what is feasibility study? Well, the feasibility study is conducted to examine candidate areas. It provides an outline for business and technical solutions which have been suggested. It involves processes of fact gathering. And what does it produce? Well, it produces a very simple thing called feasibility report. Well, what should be the basic component of feasibility study, or what are the basic assets or basic traits of feasibility study? Well, to look at, it's a quick but dirty systems analysis. It is undertaken in tight time frame, and it may lead to commitment of large resources. Probably feasibility study is the one which you might have to undertake in any industry before you submit a proposal. Probably that is part of the feasibility study which you are submitting over there as a sort of proposal. So you really have to undertake, and probably you have to do things, put resources and do the things in such a fast fashion that you are working at a breakneck speed. And if you miss by any chance at this point of level or this level, probably later on you face the consequences. So that's how the importance of the whole aspect is. But what are the basic things which we do in feasibility study? Well, the very first thing which we have to do is technical feasibility, which basically is concerned with specifying equipment and software requirement to support the project. Well, the example for in this particular regard, as we can quickly see, the facility to produce output in a given time scale, for example 20,000 examination certificates in 1 week. This is just a simple example, but in a banking environment it may be satisfying some of the requirements of producing the account balances or reports of thousands of customers which may be there. The second may be the operational feasibility. Now, operational feasibility is concerned with what are the job changes? Is organizational structure disturbed? What new skills be required? Do the current employer possess those skills? Training time needed? Basically, operationally, whether a given system is feasible or not. Okay, but the most important of the feasibility stuff which you really have to do, once again we go through quickly, it's the economic feasibility. Whether your project is economically viable, the cost benefit analysis, that is, the cost of the project is assessed against the benefits, and this is one of the most important condition for determining the feasibility of any project. What is the outcome of the feasibility study? Well, outcome of the feasibility study is the feasibility report. What does feasibility report contain? Well, the introduction, where background of the project is to be told, report layout, terms of references, what is expected, time frame, what resources are available, basically specifying some basic facets. But in addition, we need to talk about the existing system, results of the facts finding, whatever facts we have found, facts are presented using DFTs and logical data structures, that may be possible. Then we need to talk about system requirements derived from discussions with system users, audit, security and data protection implication. I think this is one of the most important issue, that is audit, protection and data security feature, which is missed by most of the software engineer. As a software engineer, this should be your first considerations. If you don't define it, you're going to lose many things out of your project. Other things which you have to specify in the feasibility study report happens to be the proposed system. A number of options may be considered. Out of that, you are going to suggest one. Outline design is to be proposed by the definition of key input and output, advantages, constraints of the proposed system, along with the developmental plan for detailed analysis, design in case of feasibility study acceptance. Well, project plan has lot of implications, because project plan is one area or one place where you are committing lots of resources by the organization for a particular project. So once your acceptance of feasibility study is given, you are given a go ahead kind of a signal, the first important thing which you do along with feasibility study most of the time, but at that point of time you just give a rough plan. The most important aspect is planning, and if you have done right kind of planning, you will be sure of the quality, you will be sure of the traceability. In fact, traceability somehow we cannot link to this particular aspect, we'll link it to the feasibility to more aspect, and you will be assured of the timely delivery of the product, along with, and definitely if it is timely delivered, in most likelihood you are going to have some sort of budgetary or financial control onto the system, which are one of the most important factor in the planning phase. Let's look into the key facet of planning. What is project planning? It is the most important ability of a manager. Okay, so what we are saying is the most important ability of a manager is the ability to know what will go wrong before it actually does, and courage to estimate this cloudy future. In fact, that's what you will be, the project planner, after, let's say, a year or two in the industry. You need to have lot of courage. You need to find out where the things can go wrong. And is it a one-time planning thing? Probably not. Project planning goes on. It keeps on changing along as the project is going on. Okay. Well, what are the objectives of the project planning? Well, the basic objective of project planning happens to be, it provides a framework for making reasonable estimates of resources, cost and schedule. Estimates should be updated regularly. This was the point I was talking about. Planning objective is achieved through a process of information discovery. Okay. In addition, you need to develop a project plan also. Now, what are the key facets of the project plan? Well, the project plan need to provide the project objectives. What are the objectives which you have foreseen for a project? For example, if you are looking into the banking sector, probably one of the objective of your project will be to develop a software in a specified time frame, right? Specific products which are to be delivered, maybe the account management system, activities and milestone. To achieve that particular product, what activities are to be performed, which basically encompasses the software developmental process, and the milestones, that is, at what point of time, what deliverables you are planning. Now, deliverables can be of many types. Okay, deliverable is just not the software. Deliverables can be in the form of a project documentation. You are giving a design documentation. You are submitting a SRS, software requirement specification, and getting some kind of feedback out of it. You are submitting the code and the user's manual. You are submitting the test reports, and ultimately you may be submitting or giving the whole project along with its necessary documentation. Technical, which includes analysis, design, user requirements, the coding part and the testing part. So like that, the deliverables are many and they are to be delivered at various points of time. List of project activities. What activities you will be doing. So that is once again to some extent same as the activities as we have touched upon in the last point. Resource requirements, one of the most important factor. Schedule using Gantt or PERT chart, and finally the budgetary estimates. These being once again we go back to the same old principle of planning. We need to keep on revising our plans. And mind it, you are working in a situation now where everything has already been committed. During the feasibility study, something has already been said. Some financial estimates have already been given. How to change them? How to change the deliverables? Probably there are ways of doing things when you are dealing with a mega software development project. There are shifts, there are changes, because requirements keep on changing. But that is the part or the way, and you have to keep in mind. For example, if you are looking into the spiral model of development, of software development, probably in the first spiral, you may just end up creating SRS. In the second spiral, you have just produced the design report. So the things, your estimates keeps on changing, even the budgetary estimates. And if it is an in-house model, quite easy to convince the people. But if it is, you are developing it for somebody, a client, sometimes it becomes difficult to convince him that this much money, this much more money he has to purge out. Anyway, there are ways, means by which you have to and really have to extract those kinds of things, but that is part of something later on what you will be doing actually in the industry. For the time being, once I have done the planning, what do I do next? Well, I need to do some analysis work, and that is the software requirement analysis. What are the basic steps of software requirement analysis? Just 5 steps: recognition, evaluation and synthesis, modeling, specification, and finally the review. What does problem recognition mean? Doesn't I have done it earlier? I have. I have got that particular report, but have I understood it correctly, properly? I need to do something about it. And in the problem recognition, what are the basic issues? Understand the software in the context of the system. In the overall system, where does your software stand? Generate scope of the problem, along with the constraints, the limitations, the budgetary limitations, and all those things put together, that this is the scope. Okay, I'm not going beyond this, beyond that. Get the problem recognition from the viewpoint of the users and customers. Basically pinpointing one basic thing: you need to interact with the users. One of the common technique to interact with the user is facilitated approach. Facilitated, we call it FAST. Basically, it's a facilitated approach where a coordinator calls the people at a particular place, conducts the meeting, and tries to extract the requirements out of the persons. Problem, understanding, and maybe doing further analysis of the problem in the form of understanding the user's need. Okay. What are the questions which we may have to ask in case of analysis? Well, some of the questions which you need to ask is: who is behind this request for this work? Why this will be needed, this question? Well, here goes the traceability. You have implemented a function ultimately in a software, but who will be getting the benefit of it? Who will use the solution? You want to know about the users. What kind of framework they are working with? What kind of interfaces they can be more comfortable with? Okay. What will be the economic benefits of a successful solution? Definitely this is, once again, as a point of view, like before it is too late, there is no harm in looking back at certain things. What will be a good output from the user's point of view? So you are just looking at some of the basic requirements. In addition, some more questions which can be: what problems will this solution address? What will be the environment of the solution? What may be the constraints? So basically you are trying to identify problem to a very great extent, okay, by asking various questions to the right kind of the users. So probably you have to find out the right kind of users too. Otherwise, you won't be able to find the right kind of query or right kind of answers to your this thing. Okay. Mind it, this is the question which is normally asked by the systems analyst. Are you the right person whom I am asking this particular question? And if you are not, whom I can address this particular question to? So these are the common things which are asked. You will be facing it. The next state is problem evaluation and solution synthesis. Once you have asked many questions to the people, you have found out what you want or what the users are saying, what are the basic requirements, a basic understanding, then you are evaluating once again. What you are doing in the evaluation? Define all externally observable data objects. Evaluate the flow and content of information, how information is flowing among those. Define and elaborate all software functions. Understand software behavior in the context of events that affect the system. If we closely look at these four things, we are trying to point some modeling features. Okay, what are those? Well, very shortly we will talk about that. Next is establish system interface characteristics. Find additional design constraints. Each of the above describes the problem so that overall approach of solution may be synthesized. Okay. So basically what you are saying is you are analyzing your problem. You are trying to go deeper into the problem such that a solution or ultimate design for implementation is obtained. But at this stage, probably the basic solutions. What are the principles of analysis? Well, the information domain of a problem must be represented and understood. What is the information domain of any problem? The data structures, the control data. So any data which is available, that is the information domain. The function that software is to perform must be defined. Probably we are looking into some kind of functional requirements or functional modeling of the software. The behavior of the system must be represented. How the system behaves if you click onto a particular button. What will be the outcome? Probably we are talking about transition, state transitions. Okay. The models may be partitioned to reveal information in hierarchical fashion. This, I think, is one of the most important things, that you should try to organize most of the things in as hierarchical fashion as possible. At the top level, you try to describe the basics, and as you are going down towards the hierarchy, you are designing more and more elaborate features or more and more elaborate things about the problem as you are understanding more and more about the problem. There are certain guidelines for this particular analysis step, and that is understand the problem before you begin to create analysis model. So before you go to third step, you understand. Develop prototypes that enable a user to understand how human-machine interaction will occur. Well, this particular step can be taken at any point of time as far as analysis is concerned. The prototype today has been accepted as one of the analysis principles. You design prototype, you develop prototype, which is presented to the user with required machine interfaces, and user is asked to comment on those kinds of things. So what is it? What is prototype? Just to remind you, prototype is a rudimentary implementation of what you perceive to be the problem solution. Okay. Record the origin of and the reason of every requirement. This once again boils down to the traceability issue. Other guidelines may be use multiple views of requirements, multiple models in fact. Prioritize requirements, prioritize them, implement them accordingly. If you are doing with, let's say, spiral model, probably you will keep on implementing different different requirements one by one. Work to eliminate redundancy. There is no scope for redundancy as far as problem analysis is concerned and problem analysis representation is concerned. Once I have done this particular task, as I was talking about, there are pointers. What kind of models I have to develop as I have done the basic problem understanding and solution synthesizing. Well, modeling basically boils down to, it has the three basic objectives: to describe what the customer requires, to establish a basis for the creation of software design, and to define a set of requirements that can be validated once the software is built. So probably this is the point of time when I'm trying to define certain basic functional requirements which need to be tested later at the time of implementation. What is the core in any modeling technique? Well, the core of any analysis and modeling is the data dictionary, which basically is the organized description of all the data objects consumed or produced by the software. It contains the information such as name and alias of item, where it has been used and how it has been used, the content description, and any other specific information which may be required about that particular thing. The next thing which we have to do in modeling is data modeling, in which what we say, what are the primary data objects to be processed by the system, what is the composition of each object, and attributes describing the objects, what are the relationships between the objects. Entity relationship diagrams are used to represent data objects and their relationships. Whatever you do comes back. Entity relationship diagram, you know about them. Where are they being used? Most importantly, data models. The data, what kind of data is to be stored? If it is a database project, but even if it is not a database project, even then the data structures and its requirements can be modeled through entity relationship diagram, because they may also give indication of file system requirements, right? The second kind of model which you might have to go for may be the functional modeling and information flow. The data flow diagrams are used for this particular purpose, for functional modeling. That is how various functions will perform or process data, and data will move from the basic inputs and reach to a particular output stage. DFT provides indicator of how information flow through the system, depicts the functions that transforms the data flow. A description of each function represented in DFT is contained in process specification. In fact, the last point is once again most important for you to understand, that the description of the process is not contained in the data flow diagram. Process specification is to be generated for it. third but not the least is the behavioral model, which basically indicates state transition diagram, which represents the behavior of the system. It depicts states and events that cause the system to change state, and it also indicates the actions, for example process activation, to be taken. As I was talking about, suppose you press mouse button on a particular icon, something happens, and that is change of state. Right? So once you have done all these things, that is the first 3 steps of requirement specification or requirement analysis, what do? You need to generate a software requirement specification. And if you have a software requirement specification, the next step will be to review it. But what kind of software requirement specification I need to generate? What I should put into the software requirement specifications? That is, what should be the content of it? Once again, it is one of the most important fact or requirement in any software engineering team. And this is something which you will be progressing throughout your life. It is one of the most interesting aspect of software engineering. In fact, not most interesting, but then at least it is not least interesting also. Okay. Now, what is an SRS? What does it contains? Well, the SRS documentation style which I am presenting here is IEEE standard for documentation of software requirement specifications, right? It recommends the first thing to be said is table of contents. If you don't give it, your document is simply thrown out. The first point to be given is introduction, where you define the purpose, scope, definitions, references, and overviews. Well, the term seems to be okay, but what in a nutshell I would like to put in this particular section? Well, the explanation for that is, I would like to put comments about the intent of SRS in the introduction. I would like to put purpose, intended audience of the SRS. I would like to specify product, function, benefits, and goals of this particular place. Terms needed to interpret SRS. Many abbreviations we define, we never define them we never come to know what those abbreviations are all about. Acronyms, abbreviations. Documents referenced in SRS. What documents which it will be referencing? Any technical document or any industry related document? All those references are given here. What SRS contains and further organization of SRS. So the future pointers are also given in this particular section. What is the second subsection of SRS? Well, it provides the overall description of the products. It is product perspective, product functions, user characteristics, constraints, assumption and dependencies, and apportioning of requirements, dividing the requirements into specific things. But what does all these things means? Let's have the explanation or look into the explanation for it. You need to describe factors affecting product. What factors? Environmental, quality, which may affect your product. Context. Under what context or related products you are talking about this particular product? Are they already existing? Major functions software performs. What are the major functions? Just an overview. Intended users, once again the traceability which you have said probably will be used here. Any changes affecting requirements. Okay, if you change anything or what any changes which may affect the basic requirements. Can be foreseen, some of those but not necessarily all. Items delayed until future version of software. So you may not be looking into all the requirements, you might have to propose some of the things later on. What should be the content of next section? So once what we have done, basic introduction, basic product perspective, then we boil down to the details. And details are basically specific requirements which we do for almost each module or each subsystem of the product which is to be generated. What are those things? First is the interface requirements. Very first thing. Second is the functional requirements, that is data flows and all those. Performance requirements. Now this is what specification ultimately will be most useful from the quality point of view. Anyway, quality need to address the issue of interface also, whether it is a quality interface, whether it is quality functional implementation. How many errors are there? Not many things quality has to address to. Logical database requirements, design constraints, software system attributes, and organizing the specific requirements. Let's look into once again the explanation side of it very quickly. Give sufficient detail to enable designer to design system that satisfies requirements. So this is the one of the basic objective of this particular portion. We need to specify the users, the hardware and the software, and the communication requirements. We need to identify basic processing actions of the system, that is the functions. We need to specify static, dynamic, numeric requirements of hardware and software. Okay, the changing requirements, anything which is going to change. Specify any information placed in database, if it is to be done at all, and constraints imposed by the standards. Okay, there are multiple standards. Software development process these days involves around all the standards. Standards for documentation, standard for implementation, standards for coding. Always we are dealing with standards these days. Software attributes serving as requirements, and how to organize specific requirements. So in nutshell, all this information has to go, and in addition some supporting information also has to go into the software requirement specification. That's why it is one of the most important activity in any software development process. Supporting information may be table of contents and index. Once again, we already developed the table of contents was the first one, and index may be an additional things. And normally we provide appendices. Normally the model which we develop normally constitute as part of the appendices. Anyway, let's look into this the explanation part. That is, it supplies roadmap for readers of SRS. It identifies location of SRS items, supplies sample IO formats, description of cost analysis studies, results of user surveys, supporting of background data to help readers understand the SRS, packaging instruction for code to meet security, export, initial loading, and other requirements. Basically, details goes as far as appendices are concerned. So with this we go to the client. Here is my software requirement specification. In fact, this is what I'm going to do for you. And client approves it. It takes time for approval because review is done. Review is a constant updating process. It's not that at the first time you will get everything approved. Although waterfall model does not support it, yet that is the way. So we go to the next step. What is the next step? The design step. Once I have done the basics analysis, then I need to do the designing part. And design is a multi-step process. What does it involve? Design for data structure, software architecture, interface representations, procedure, that is algorithmic details. Basically, this is the step which translates requirement into representation that can be accessed for quality before code generation. So here the first quality check is going to be based on the requirements. Okay, but the check will be here whether your design is quality conscious, okay, address all the issues, fulfill all the constraints, has test item been specified, have they been specified correctly, quality checks. So this is what you will be doing, and that is where you will be caught. Okay, so before the code generation, this is where you might be caught initially, but as you progress, this is where you will enjoy, or you will do the best or the better part of your actions. Anyway, analysis is equally interesting and important for you people. Data design. What do we do in the data design part? In the data design part, we transform the information domain model into data. Okay, data structures required for implementing software. ER diagram and data dictionary form the basis of this design activity. So basically, we are trying to identify certain data structures which are to be implemented, or databases which are to be put into the static part of the data. Then we do the architectural design. What does architectural design do? It defines relationships among major structural elements of a program. The modular framework of a computer program and data flow diagrams form the basis for this. What is architectural design? You had implemented data structures using C, and you have also done object-oriented programming. In data structure implementation, how do you implement? You design various functions which support, for example, stack, push, pop, stack empty, stack full. 4 functions are there doing different jobs. In object-oriented programming, data is being further encapsulated and doing this particular job. A particular job is expected out of a particular object. What we are saying here in the architectural design, if stack-based implementation have 4 procedures, that's an architecture. How they interact with each other, that's an architecture in the simplest of form. In object orientation or object-oriented programming, the architectural design is slightly at a higher level, where you are talking to different objects and you are specifying different functionality, data, everything attached to it, and only thing is you put various bits and pieces of objects together and form a code. Maybe all those are acting as separate modules. Okay, separate modules of objects, and there are interaction pieces being provided by you and doing the job. Probably the similar kind of thing you are doing in the main program when you are talking about the procedural level implementation. The whole basic aspect in the architectural design is that you are specifying various modules which in most likelihood are acting independent of each other. Okay, so that is the basic design principle for the architectural design. Interface design. Well, this is one of the activity which most of you do at the fastest pace. This basically describes how software communicates within itself to systems that interoperate with it and with human who use it. Data flow diagram once again provides the information, in fact mostly in the form of wherever the interfaces etc. are needed. Procedural design. The basic idea of procedural design is that to transform structural element of the program architecture into procedural description of software components. So it is a lower level design, procedures. Information is drawn from process specification and state transition diagram serves as the basis of information. So using these two, you try to generate basic procedural level details which are to be written. Okay, so that's how probably you are creating a superclass for an object because you are implementing it. You are implementing a communication process. What are the basic design principles which you have to adhere to? Well, the first and the most important is the design process should not suffer from tunnel vision. Most of the time we look at just one kind of implementation. The design should be traceable to the analysis model. To what requirement? Maybe one particular function may be result of many requirements, or maybe result of multiple functions, may be result of one requirement. However, the traceability should be ensured. The design should not reinvent the wheel. Objects should be reused. This design should minimize the intellectual distance between software and problem. Okay, so basically you are moving a step, you are moving one step ahead towards implementation. That's what this particular act is going to do. The design should exhibit uniformity and integration. The design should be structured to accommodate change. The design is not coding and coding is not design. Most important to hear that. The design should be accessed for quality. Should be assessed for quality rather than that, as it is being created. It's not that to final design you will be assessing only for quality. The design should be reviewed to minimize conceptual errors. So basically all the semantic errors which you encounter should be caught at this particular level. What are the features of a good design then? Okay, well, a good design should exhibit hierarchical organization, that is modularization, that exhibits good control among elements of software. Should be modular, having logical partition of software, should contain data and procedural abstractions. Okay, so good design basically reflects what you have studied in the analysis part. It should lead to modules that exhibit independent functional characteristics. Modularity, basically making objects kind of a structure, should lead to interfaces that reduce the complexity of connection between modules and its external environment. Simplified design should be derived from SRS. So these are some of the basic characteristics in the design. The document for the design should consist of some basics, that is scope of the design or scope of the system to be more precise, where system objective, major software requirements, design constraints and limitations should be pointed. Well, this particular section of the design documentation will be drawn from SRS. The next portion which should be shown is the data design portion, and in the data design portion you are supposed to show data objects and resultant data structures, file and database structures, external file structure, logical record description and access methods, global data, okay, file and data cross references. Okay, so any global data, maybe environmental setting or so, need to be presented here. Next is the architectural design section, where we need to review of data and control flow. That will go over here. Derived program structure will come here. In the interface design, human machine interface specification will come, human machine interface design rules will come, and external, that is external interface design, so many interfaces to external data, interfaces to external system or devices, and internal interface design rules. So all these basically, these are the part of any architectural design. We are just saying that a design document must contain it. Similarly, procedural. What procedural design it will be for each module, obviously. Processing narrative will be there, interface description will be there, design language or other description will be there, modules which are used, that will be specified, internal data structures may be specified for each module, and comments, restrictions, limitations may be provided. Probably it is looking after the requirements, once again in the form of procedural implementation form. Requirement cross references, test provisions, test guidelines, integration strategy, special consideration, appendices. Well, test is one of the most important thing which you must provide in the design. If you are not providing in the design, you are losing certain things. Let me tell you, there are one more advantage if you provide testing items during the design phase. In fact, it can be provided, some pointers can be provided even at the analysis phase. But even if you are providing it at the testing items at the design phase, you will be creating in fact a better design. That's how. Like, I have interacted with many designers, and whosoever had this used to do this particular activity, their impression is that I look back at, I am able to do a quality design because I am checking it. Whatever test items I am generating, I am testing the design in my mind once again at the lower level. So that way it helps. It is one of the major assets. Okay. Once I have completed my design, what do I do next? Coding, right? That is implementation, and coding is one of the major part of it. So what do we do? Just few words about coding. That why coding is needed? It translates the design into machine readable form. If there exists a detailed design, then code generation may be accomplished by the experienced programmer or mechanically. These days you are relying mainly on coding in a mechanical form, especially in the area of fourth generation languages. Gradually, similarly, you are reusing softwares wherever the software reuse and all those things are possible. Maybe in the near future it will be possible just to specify the requirements and the design properly, and the whole code generation process is over. After all, you are plugging in the gaps by putting in the proper objects in place. Why can't it be done mechanically? So in the near future, what you are going to find is coding is going to change. This scenario is going to change. Once you have done the coding, the last section is, you come to almost the last stage, and after that the maintenance and other phases start. But as far as the developmental stage is concerned, you almost come to the last stage, and that is software testing. What do we do in testing? And what is the need of testing? Testing involves logical internals of the software, involving all the statements, functional externals, performing tests to uncover errors, defined input should lead to defined output. So there are two basic testing methods probably we are pointing to. Maybe we will look into some more details about them slightly later. Okay, so these are the two basic strategies for testing, internals and functional externals. What are the basic testing principles? All tests should be traceable to customer requirements. That's how, if I designed it at analysis and design phase, they will be traceable. Tests should be planned before testing begins, never do otherwise. Testing should begin individual programs and then to module. So you are starting from the bottom up. Designing you are doing top down. Testing you are doing bottom up. Exhaustive testing is not possible. Now that's a very interesting thing to say, that exhaustive testing is not possible. What do you mean by saying so? Well, it is possible to a certain extent. If you have, to a certain extent it is possible. The first thing which we do in testing is the unit testing. Test individual components to ensure they operate correctly. Independent component testing, that is what is the unit testing. So you are starting from the bottom approach once again. Module testing is the next step. A module encapsulates related components. It can be tested separately. The modules are components of a subsystem which may be independently designed and implemented. Subsystem testing to test functional requirement. So you are testing all the subsystems and ensuring that subsystems are working correctly. In the system testing, what we do basically, we are trying to find the errors that may result when subsystems are integrated to form a system. So we are integrating the modules and forming a system, and we need to test. What we are testing? The requirements of a system, whether the requirement of an overall system is being met or not. And for that, this is finally, after that we do finally the acceptance testing. What is acceptance testing? This is the final stage before testing process is over, before the system is accepted for the operational use. It is tested with real data, may reveal some requirements, problems or performance problems. So at this point of time, if some problems are diagnosed, it is very difficult to change, right? I think with this we come to the end of this particular presentation. In today's presentation, I have presented to you a complete software process for software development, mainly revolving around waterfall model, but it is applicable for any other spiral or any other kind of model. With this, bye for now. See you in the next session.